We finished on what?
With loops.
Oh, loops, okay. And so what are we going to do today? July 18. We can go on to arrays, or we can review. What do you want to do? Review?
Yeah.
Is there any particular problem you want to look at, or any idea that you're working on? Huh? Example functions? Like in here?
Activity. Yeah.
There? Down the bottom here?
Number 4.
This one?
4.
Oh, 4.
Exercise.
Oh, this one. So a person's initials is the first letter of their first name followed by a period followed by the first letter of their last name followed by a period, for example, dot. Write a program that prompts the user for the first name and then prompt the user for a last name. Have the program display the user's initials. As part of your solution, define a function named initials, which takes 2 arguments, the first name and the last name. The function returns the person's initials as a string. Because the function arguments don't need to be changed and are complex data types, you should pass them into the function as const references. And this hint here, I was going to change that because substring works, but then the index operator is also good. Now, let me change it right now. That's not the best hint. Use the substring function of the string data type. Use the substring function or the index operator of the string data type. There we go. So let's look at that. And here, let's see if I am set up to run here. Should say okay. There we go. So we want this function called initials. And it takes a const, a string reference for the first name, and a const string reference for the last name. And then it's going to return a string. So let's just hard code it in there. So this is called a stub. Function stub doesn't do what we want it to do. We're just putting it in there as a simple implementation, as a step forward to solving the problem. And then we'll prompt the user for first name and last name. And then prompt the user for the last name. This could get complicated depending on how you want to do it. I'm going to do it the simple way where a name has no spaces in it, you know, like some names, I can't think of any now, de Tocqueville or something like that. There's a few names like that. Right? So we're going to ignore that case for now. And then we want to output the result. So we call the function initials with the first name and the last name. There it is. So let's test that. Seems to work. That doesn't really work, does it? Because it always returns dt, because it's a function stub. So we got the code set up. The outer shell of the problem is solved. Now we need to get the inner core of the problem solved. How do we return these initials? Let's think of it like this. So let's start by just returning the first letter of the first name. So just do this. That's the index operator. Oops. That's a character, isn't it? First name 0 is a character, so this would have to be a char like that. So it correctly pulls the F off a Fred. But we don't want a char, we want a string here. We can turn this char into a string by just appending a dot. So this operator here will accept on the left-hand side or the right-hand side a char, but the result will be a string. So I don't know if this is a char as well, whether the result is a string. It probably is. It's not the right one. So chars are represented with apostrophes. This will not work. There we go. Let's see. If I have a char on the left-hand side, see the index operator doesn't return a string. It returns a char. It's the char at position 0 in the string. And then we want to concatenate that with the char period. Does this compile? It does not. This has got to be, that has to be a string. So one side has to be a string in order to for the operator to be defined. Actually, it doesn't print anything, does it? Let's take a look. How come that doesn't print anything? That doesn't make sense to me. All right, I got to do some investigation. What's going on? What if I did this? Does that produce what I think it produces? It does not. What if I did this? So what's going on here? Let me try this. See, it says invalid operands, so it doesn't take, this is a constant char 2. I don't know where it gets that from. And a constant char 2, it has 2 constant chars. I don't get that. Oh, because a string internally in memory is this string that I have highlighted right here, internally in memory, is a 1 byte for the period, and then it has an extra byte for a 0. So these are actually represented by 0 terminated sequences of chars. That's why it's saying it can't deal with this. It's constant char 2. So it's looking at this D and the period as 2 char sequences of 2 characters. Or not 2, yeah, 2 chars, with the last char being a 0, which is not visible to us. So this doesn't work. How do you do concatenation? So let's do it like this. I think plus equal is defined. Let's initialize S to D and then try to concatenate a period. That works. Now we got it. So actually this plus is not defined. So I was, other languages this will work without problem. Yeah, but this language is not working. So we start with the string S. We can do it like this. And we can append onto S the characters that we want. So first a D, then a period, and so on. So we'll use that pattern. Then return S. So we create an empty string S, append a D, append a period, return S. So, what I had here, this is simply not defined. Now this plus operator doesn't work. Can't handle a char in a string, or can't even handle two string literals. Oh, you know what? Remember I said that this, I'm going to show you something here, just to show you how tricky this stuff is. Once again, this is an old language and hard to work with. I don't know why we're using it as our beginning language here in our program, but we do. And so what happens if we did, this will not work, right? We established that. This D plus period does not work. It's not defined. But I think if I just do this, put these 2 strings together like that, the compiler will merge them. Do you see that? So that this syntax is taken because these are called string literals. They're not variables. So the compiler will accept 2 string literals, in sequence and merge them together for us. So we don't need to use an operator that evaluates at runtime. We use a merging that's evaluated at compile time. Now look at how much I'm learning just by tinkering around with this. All right, so now that we've been playing around, we think we've mastered this now, right? We're playing around with this. Now we'll use this char here. Well, I believe this is different. Now we're talking chars. Now we're appending chars onto a string, and this is, I believe that's okay. Start with a string s, which is empty. Otherwise, you could say it like this. You could do string s equals empty, but this is the default. If you create s without initialization, the string s without initialization, it will be empty. And then we're going to append these chars and then return s as a string. Let's see if that takes it. Looks good. And we got to get the last name in there. So we get the first name, followed by a dot, followed by the last name, followed by a dot. That works. So that turned out to be harder than I thought. Although it should be a very simple problem. Once again, in other languages, it's a lot easier to solve. Do you want to see how to do this with substrings? A substring, let me show you how to do it with substrings. So here, I'm going to do it in one line. So we take the first name, dot substring. Now substring doesn't return a char, so it makes it easier. Substring returns a string. So let's get the first character. So the character in position 0, the substring that starts in position 0 and contains one character. So that's the first letter. And then we'll append a dot, and then we'll do the same thing for the last name. See that? It's all in one line. We take the first name, pull out the substring, which consists of the first letter. We could pull out more than one letter. We could pull out 2 letters, like that, right? Or we could pull out 2 letters starting in position 3. Right, that's how subs, but we want to pull out 1 letter starting in position 0. So that's a one-line implementation that uses substring. This is a multi-line implementation that uses the index operator. By the way, this is called the index operator. We index into a sequence. And the operator inside these brackets, you see the index, which is the position number within the sequence. So this works with strings, it works with arrays, it works with vectors. Those 3 type of objects, the index operator is defined. It works in a straightforward way. Any questions on this one? Any further questions? Yeah.
Can you look at mine? Just tell me if I was going in the right direction.
One more time.
Can you look at mine on
Oh, yeah.
just to see where I'm going? SH.
Sheldon, right? Oh, Sheridan, rather, Sheridan. So it's, which one is it? Number 5?
Number 4.
4, this one, right?
Yes.
Oh, you want me to look at this one?
No, under functions. If you open the functions tab.
Oh, under functions.
Yes.
Sorry.
When I ran it again, it asked me to do the same thing as last time when I asked you to put the apostrophe in the middle of the C out. So, I didn't know what to do there.
Let me take a look here. Oh, it's a compilation error. Expected semicolon before the string constant. So line 17, which is here, column position 35. I can see it down there. That's 1736, 1735. So you're missing this. What was it? You see that? It doesn't know what to do here. And this operator needs a right-hand side. This is the right-hand side. But and then this evaluates to C out. And then C out is followed by a string with no operator. Yeah, string literal. There you go. Oh, same issue here. And here. What's going on? It doesn't stop looping. So we define 2 chars. We define 2 strings. Also, you need to use a function the way I showed it. Please enter your first and last name. Get line first name. And then first name. Get line last name. Last name. So here it's waiting. This is it's going to keep reading from C in until it gets to a space. So I had to put a space in there. And then Turner. Because this, after we hit the space, then we do another get line, and that reads until we hit a new line. So that works. So that's, and if you don't do it like, if you don't put a space in there, if I say enter here, see it's waiting for a space. See? I put a space, got it? And then it reads it, and it gets nothing for last name because, you know, it reads through to the end of line. You can do it like this. I mean, yeah, just, it's tricky, huh?
Should that space not be there?
I don't know. It's, how do you want the user to enter things? You know, the problem is not that good. Like I said, I would do it like this. If you leave this out, it's the same as doing this. This is the default. The default is a new line. So just omit that, and it'll read until it hits a new line. So first you read the first name, but you want to prompt them to enter the first name. And then prompt them to enter the last name. You could tell them what to do. So you want to put some spaces in there, right? Well, you want to put that in there. You know, put a space in here. But you have to use a function. This all should be done inside of a function. And so use that plus equal operator, the concatenation operation with strings, rather than having a string like this. Once again, this language is not convenient. And, but it's normally, you don't use C++ to, I mean, normally you're not writing programs that operate at the command line. I mean, there are command line programs. A lot of software developers use command line programs. So those programs need to be written like in this way. But the typical program has a graphical user interface, and it's not receiving input from the command line. Instead, it's receiving input through things like text boxes or button presses or selection from drop-down lists. You know, graphical user interface components are used that generate input events that your program will handle when they occur. So this is not the standard way to get input from users. It's a common way to get input from software developers that are using command line tools. That's true. All right. So anything else? I'll get into arrays then. You all ready? Ready for arrays? You want me to go over an exam question? Which one? Which meeting number? Functions? So let me see, I have advanced exam questions here. Oh, I started posting the answers, by the way, right? So, did you want me to talk about this one? Right. Implement this isLucky function. A number is lucky if it is divisible by 7, but not divisible by 13. Now, on the exam, you don't need to implement a program. You just need to provide an answer. That's my answer that I would, expect to see from you on the exam. If you wanted to give me more, like put it in a function, wrap it inside this function, and then define a main and call it with test code. I mean, that's what you would do as an assignment at home with extra time. But in the exam, I just want you to provide the implementation details of the function. You don't even have to rewrite this function signature here. Just assume that you're inside this function, then implement it like this. Oh, this is not, I didn't need to do that there, did I? I thought I had to escape these, but apparently I don't have to do that. See, this is a escape sequence. This says I want an ampersand to be visible. That's a HTML entity, they call it. I just want it to look like that. There we go. Sorry about that one. That is the answer. So let's go all out and implement this thing. But you know, this is not what I want you to do on the exam. I want you to just show me the implementation of the function. I'm going to bring in a header called CSUSB. We'll use this later and maybe in the next assignment. These assertions. I'm going to do a stub here. I'm going to return true. N is lucky. It's always lucky. That's called a stub. It's incomplete. And you know, we can print. We could do this. If 7 is lucky, then print seven is lucky. And if 13 if is lucky passing in 13 returns false, then we're going to say 13 is not lucky. Right? If is lucky 7 returns true, we're going to print 7 is lucky. Else, we're going to print 7 is not lucky. So I'm developing test code. So if is lucky, actually let me do it like this. If is lucky 13, if is lucky returns true for 13, then we'll print 13 is lucky. Otherwise, we'll print 13 is not lucky. So it should say 7 is lucky, 13 is not lucky. And these are the test cases. And there's another test case. What if we did 13 times 7? What's 13 times 7? 91, right? 91. So 91 is, it should say 91 is not lucky. And once again, we have a stub here, so everything is returned as true. Oh, wait a minute. Yeah, I'm good. 7 is lucky, 13 is lucky, 91 is lucky. Well, it's wrong, right? 13 is not lucky, 91 is not lucky. Okay, but we got the shell of the program working. We got the test code developed. And now what we're going to do is to implement the function. So, you know, if n mod 7 equals 0, then maybe it's lucky because it's divisible by 7. But we also have to have, so let's do it like this. If there's so many ways to do this, let's do it like this. If n mod 7 is not 0, then return false. You can't be lucky, right? You can't be lucky if 7 doesn't divide into n, then n is not lucky according to our definition. And if n mod 13 if n mod 13 is 0, if 13 divides into n, it doesn't matter if 7 divides into n. It's not lucky. We return false again. In all other cases, we return true. Because in all other cases, we have that n mod 7 must be 0, and n mod 13 must not be 0. So that's our definition of lucky. So we could write it like this. This is one way to write it. Let's see if we got it. 7 is lucky, 13 is not lucky, 91 is not lucky. That's correct, isn't it? But maybe it's hard to read this. Maybe it's hard to grasp this logic here. So to make it easier. So we have to have that n mod 7 must be 0 in order to be lucky. Let's write the case down that n is lucky. So we have to have that 7 divides into n evenly, and that 13 does not divide into 7 evenly. So n mod 13 is not equal to 0. If that's the case, we'll return true. We're lucky. N is lucky. Else, let's return false. N is not lucky. See, that's easier. Is that easier to comprehend? Is that easier for you to mentally map to the problem statement? And most of programming, the concern is not efficiency. Most of the time, the concern is readability. So you're always seeking ways to make your code more readable, not necessarily more efficient. Efficient is good if it's important. But in this problem, there's no consideration of efficiency. It just doesn't matter here. But it's all about readability. Can the programmer writing the code understand what he or she is writing? And can other people understand the code as well? So we need to reason about the code. So we're searching for a way to make it easier to work with. Now my solution, I just did this. This is the solution I gave. See, that's a one-liner that solves the problem. Let's try it with our test code. Looks good. See, because this expression evaluates to true when n is lucky, and it evaluates to false when n is not lucky. So let's just return the result of this expression. See, this is a lot of extra writing that's not needed. So you'll see programmers will use this form in line 17 as opposed to lines 11 through 15. You generally see it like this. Although when you're starting out, this might be easier for you to process. Because remember, you need to return true or false. It's a Boolean function. You have to return true or false. And this expression is a Boolean expression. This expression evaluates to true or false. So that's why we use it inside of an if statement. But this is a lot of redundancy here. If this expression evaluates to true, return true. Otherwise, return false. Well, let's just return what the expression evaluates to. You see that? So we'll cut out that little extra verbiage that we don't need there. So that's a more compact form of this function. Now this code here requires visual inspection. I have to look at this, say 7 is lucky, 13 is not lucky. But in the coming assignments, maybe not on this exam, but in the future quizzes, I want you to write this test code differently. Let me show you how I want the test code to appear in the future assignments. I want you to use this assertion. This assert that is lucky 7. Assert that is lucky returns true when we pass in 7. That's the same as, whoops, sorry. Instead of printing this out, because what assert does is it takes this expression, and it evaluates the expression. And if the expression evaluates to true, the assert function says everything's okay, just carry on. But if the expression evaluates to false, then the program will terminate at that point with an error message. So you're asserting. I'm saying, I say it's a fact that 7 is lucky. That I say as a fact that is lucky returns true when we pass in 7. I'm asserting that. And if you see a problem with that, let me know. And if you don't see a problem with that, don't say anything, just be quiet. Let me show you how that works. And we do it for these other ones as well. So these are called assertions. Is lucky 13, that should return false. Is lucky 91, should return false. Then we want to say something. So we're going to get to the end. We're going to say all tests passed. So if we pass through these assertions silently without terminating the program with an error message, then we'll get to the last statement, which is to print all tests passed. All tests passed. Now let's see, what if we said this? What if we thought that instead of 13, we put a 14 in there? If we pass 14 into is lucky, what should it return? It should return true, right? 14 is divisible by 7. According to our definition, 14 is lucky. It's not divisible by 13, and it is divisible by 7. So this should return true, but we're asserting that it returns false. So we're making a false assertion. So the program will terminate in line 23, and we will not arrive at line 32. We will not say all tests passed. Instead, we will terminate at line 23 with an error message. There it is. 23, line 23, assertion. Assertion is lucky 14 equals false, failed. That assertion failed. Now this is how I want you to write your test code in the future. Now, real test code out there in the working world is written similar to this. It's not exactly like this, but people write test code in different ways. This is one way to do it. And this is similar to how it's generally written anyway. Yeah.
If you're saying we're supposed to use assert later on, how were we supposed to use it for this assignment when we were supposed to test asserts?
Oh, you can do it. This is not an assignment. This is a quiz, example quiz problem. This is how I want the answer. You could answer just a one-liner like that. This is how you implement is lucky. I'm just talking about something else now.
I understand. I was saying because one of the things I got downgraded on from Mark was on a lot of these ones I had to test my code with assertions.
Really? Did I ask for oh, here.
Yeah,
Oh, I did ask for assertions. Write test code with assertions.
and I think the first one you gave example assertions about it too.
Yeah, so these are examples of the assertions. I just didn't talk about it. Did I talk about this before? I didn't. This is my first time talking about it.
First one.
So that's the reason for that. Actually, I'm requiring you to use assertions here. So did you do this first one correctly with these assertions?
The first one, I did some of it correctly, but I got marked down because I did test with asserts.
I see. Like this, right? This is this assert header. All right, well, that's what's going on there. So will be important. For the rest of the course, we're going to use assertions. I'll talk to you later about your grade, okay?
I just wanted to know.
Yeah, that's what's going on. And thank you for letting me know. It's the time to talk about assertions, and so I'm talking about it now. And these were due last Friday?
This,
Oh, they're due this coming Friday.
no, last Friday.
Oh, last Friday. Okay, so I'm a little behind for my presentation. All right. All right. What about, should we talk about loops?